Okay. Hope you're having a good day. We're continuing in Unit 3, which is our second unit of study, but it's all about parallel and perpendicular. And today we're going to talk about parallel and perpendicular lines. So again, you don't have to take notes on this first page, but I want you to think as we're talking about these, because it's all really being driven again by the relationship here between two lines and transversals. And what we know, if we happen to know that those lines are parallel, then we know a lot more than if we don't know they're parallel. So a transversal intersects at least two lines, always. It may intersect more than two lines, but it has to intersect two lines. A transversal sometimes, always, or never intersects two lines at more than 2 points. A transversal sometimes intersects two lines at more than 2 points. No. A transversal never is the right one. I had to think about that for a second. It never intersects two lines. I mean, it could intersect at more points if we had more than two lines, but if it's two lines, it's only 2 points of intersection. Next one, a transversal sometimes intersects two parallel lines. And again, this transversal creates 8 angles, and we have names for those relationships that you must memorize. Must memorize all of those relationships and be able to identify them. But when those lines are parallel, we don't just know the names of the relationships, we know something about congruency or supplementary. So number 4, a transversal always forms angles with two other lines. That's those 8 things. It's always. And in another video section of notes, I told you about this word transitive, right? It was this: if A is equal to B and B is equal to C, therefore, that's what these 3 lines mean. And we're going to use these when we get to proofs. Therefore, or it follows that, or we can conclude that A must be equal to C. And that now involves congruency. If A is congruent to B, B is congruent to C, then A must be congruent to C. So you have to understand that that's transitive property. Let's work on our transitive property here. What if I told you that A is greater than B? And you told me, well, that's funny because B is greater than C. What could I conclude? A is greater than B. B is greater than C. I must be able to conclude that A is also greater than C. What about Joe is younger than Ann? Joe's younger than Ann, and Ann is younger than Sam. Sounds like a Dr. Seuss poem starting off, but we can conclude that Joe is younger than Sam. Another one, if you travel from section 2 to section 3, and you travel from section 3 to section 4, then you have really traveled from section 2 to station 2 to station 4. Sorry, that should have been station instead of section. Now, here's our new ideas for the day. New ideas for the day. Parallel and perpendicular. And it's based on this transitive property of parallel lines. So if I tell you that A is parallel to B, these you do need to write down. The transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Let's make sure we understand what that says. I say it fast, but it's for a purpose. If two lines are parallel to the same line, then those lines are parallel to each other. So we start off with if A is parallel to B, and the conclusion is that A is parallel to C. Well, how could that be? That can only be if B is also parallel to C. If A is parallel to B and B is parallel to C, then A has to be parallel to C. It's the transitive property of parallel lines. Now, what if we talk about perpendicular? What about if M is perpendicular to T and N is perpendicular to T. Look at that. Those are different letters. That's M and N. If M is perpendicular to T, meaning it crosses T at a right angle, and N also crosses T at a right angle, what could we conclude about the relationship between M and N? Well, here's T, and M crossed it at a right angle, and N also crossed it at a right angle. Can we conclude anything about M and M? Is that those are going to be parallel lines. If we're both perpendicular to the same guy, then you and I are parallel. So, now let's start applying this concept. If two things are parallel to a third thing, then the two things are parallel to each other. If two things are perpendicular to the same thing, then those two things are parallel to each other. Let's start applying that. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Well, I bet we could take these 4 pieces. In fact, why don't we just turn this one, let's go this way with this one. So it would slide in there, so to speak. All right, it would slide in there. And then let's turn this one up this way. So it would slide in there. All right, so now, I left a little blank so we could see the distinguishing marks between them, but we know that this is a 30-degree angle, and this is a 30-degree angle, and this is a 30-degree angle. Oops, sorry, that was the wrong one. This is a 30-degree angle, and this is a 30-degree angle. So what we just made is a frame, like this. We know that this picture frame should have 90-degree angles like that. So we just created that. So what would happen? To make the picture frame, you will glue the same angle to the same angle, or 2 different angles to each other. Well, we're trying to form 90-degree angles, so we're gluing 2 different angles together. We're gluing a 60 to a 30. The angles are connecting end measures of 60 degrees and 30 degrees. When the pieces are glued together, we get 90-degree angles. And let's look at this. The left piece will be what to the right piece? This side over here. The left piece and the right piece. They're going to be what? They're going to be parallel. What about the top and the bottom? What about the top and the bottom? What's the top of our picture frame and the bottom of our picture frame going to be? They're also going to be parallel. Therefore, we can conclude that opposite sides are parallel. What about the relationship between the top piece and the bottom piece? What's happening right here, right here, right here, and right here? Those are perpendicular. They're intersecting at 90-degree angles. Therefore, yes, I can assemble the pieces to form a picture frame with opposite sides parallel with those 4 pieces. Now, again, big picture from that page. If 2 lines are parallel to the same line, then the starting lines are parallel to each other. And if you and I are both perpendicular to another line, then you and I are parallel to each other. In a plane, if a line is perpendicular to one of 2 parallel lines, then it must be perpendicular to the other. This is known as the perpendicular transversal theorem. Perpendicular transversal theorem. If a line is perpendicular to one of 2 parallel lines, so this, why are they showing this in this picture? Is that what we have here is this line and this line are parallel. That's what those lines mean. And they're telling us that N is perpendicular to this one. Well, what do we know? We know that N must also be perpendicular to this one, because those are corresponding angles, really is another way to think about it. Right? So use the information in the diagram here to complete each statement. A is parallel to what? A is parallel to G. We know that based on these figures right here. A is perpendicular to T. We know that based on this right here. Therefore, what can we conclude? We can conclude that G must be perpendicular to T. And I should have made these lowercase. I apologize for that. All right. And let's apply this same concept over here. C is perpendicular. What's C perpendicular to? Well, because of this mark, we know that C is perpendicular to N. And because of these 2 marks, we know that N is parallel to P. So what can we conclude? Well, I can conclude that this one has to be a right angle too. So I know that, in fact, that P has to be also perpendicular to C. That's all the notes for today. We're going to practice those 2 concepts, as well as the other concepts from this unit on Monday.